All right, so active recon. Can anyone, before we even get into this, tell me what the difference is between active and passive recon?
Isn't it like passive recon is gathering information and then active recon is somehow hitting the target?
Close. So the recon part says it's still going to be about gathering information, but you are hitting on something there. Anyone pick that up?
Passive recon is publicly available, and
Passive
active recon requires attacking the target.
Right. So active recon is going to require actually talking to the target, interacting with the target in some way. Okay, that's the major difference we're going to have here. We are crossing a threshold now, and we will actually talk to and engage with our target a little bit. So it's a type of attack, right? It's just like you said, where we are attacking to get some information, and we're going to engage with that system, and we're going to try to find all sorts of information so we can find out what sorts of vulnerabilities this target has. And so I'm going to use the word or the term enumeration pretty commonly from here on out. And it really, it comes from math. It's like numbering all of the elements in a set. So we are going to number all of the elements in a set for an individual target. So by that, I mean we're going to get all of the usernames, get all of the shares, all of the services, what web directories are exposed, any groups. And in order to do that, it's going to involve port scanning and fingerprinting. So what does that mean? Computers have ports, right? There's no bananas idea right here. They have like HDMI ports, right? The lightning cable, USB 3, right? We have all sorts of ports, physical ports. And if you think about it, it's just some way for the physical machine to interact with some physical device. And so that's an okay to wrap our head around idea. Logical ports are very similar, right? There's an interface, again, for the machine, but instead of an interface for a physical device, it's going to be an interface for another application, right? So, for example, either a client or a server, right? Programs or servers are going to be listening on those ports, and they have control over what happens, what goes out those ports. And ports are associated with IP addresses, right? So that's how they can actually talk to each other. That makes them available to the network for communication. And on top of those ports sit protocols. And all a protocol is just the language, the type of communication that the client and server agree upon, right? They're just defined sets of rules for successful communication between the client and the server. So kind of just like going through the whole like OSI model there, just keep an order of what it is that we're doing. So we're going to be fingerprinting those services. We're going to find out, is there HTTP running on that port? Is it SMTP, FTP, any kind of service like that? We're going to scan these ports and kind of get a feel for if the port is open for communication, if the port is closed, so there's nothing happening there, or if it's filtered, something's happening.
Are you going through slides right now? Because we're still on active reconnaissance and enumeration.
Absolutely. We're still right there. Haven't gone anywhere. So let's take a look at what we're going to be doing today and tomorrow. We're going to split this up a bit, and there's going to be a few places where I give you some time to work on things. We come back together and kind of follow that pattern for a bit. So first thing we're going to be doing is understanding our target, understanding our network, and kind of getting a lay for the land of where we are in PWK. So right after that, we're going to do host discovery. So find out who is on this network, right? For us on PWK, if you go into your student lab panel and you just pull down one of those drop-down menus, you can see all of the IP addresses for all of the machines. But you can also imagine a case where if this is a real pen test and you just got yourself on site and plugged your machine right into an Ethernet cable and you don't see anything, right? You don't have a list of IP addresses. So host discovery is going to be how we find those IP addresses. We're going to talk about Nmap as one of our tools, kind of like a Swiss Army knife. It's going to function as our eyes and how we look at everything, kind of get a feel for what's on the system, what ports are open, what services are running on those ports. Then we're going to talk about enumeration of different kinds of services. We're probably not going to get through all of them today for sure, because there's plenty of things you could do on each. But very briefly, we're going to touch DNS enumeration. We've already talked a bit about that, right? Host, dig, NS lookup. So we're going to play with those for a little bit and more. We're going to do some service enumeration with Nmap, so find out what services are running on a machine, and then web enumeration, because web is so big it gets its own spot. All right, so understanding the target. We have some questions and kind of thoughts we need to have in our mind as we're going through all of PWK. So first thing is, like, are we attacking a machine or a network? I mean, obviously we're doing kind of both, right? We're on this network to attack it, but we have to make sure we keep context of what we're attacking, a specific machine or a specific network. We want to know how many machines are on this network, right? We already have the answer on the PWK on the student panel, but how can we confirm this? How can we check if we did not have the answers given right to us? Which machines do I want to target to find out more information about this network, right? What machine can I ask once I find out who's on the network? Who can I ask for more information? And how do I do that? Then once we kind of have a lay of the land, who's going to give me the most access to the rest of the network, right? Who do I have to get through to get to a different part of the network? Who's stopping me? And lastly, which machines are the lowest hanging fruit? What is the easiest target for me to attack? Because that's where I'm going to go, right? A lot of folks, like I was saying earlier, they see a wall, and I give them a battering ram, and they just want to hit that wall. But sometimes you don't want to do that. Sometimes you just want to go around the side. Maybe there's just like a door that's open, right? So even though I'm going to be showing you a whole bunch of these tools, we kind of keep context and kind of make sure we understand what are the actual easy targets for me. And I'm not just going to go after everything just because I happen to have a tool for it. Okay, so let's move on. Where's my mouse? All right, so host discovery first. And let's see, there's two ways of doing this, of finding live hosts on a network. The first way is using ARP. Does anyone remember ARP from way back when? You had to watch a lot of videos with Professor Messer. Does anyone tell me what ARP is?
That's your address resolution protocol.
Absolutely. What does it do?
Tells, I guess it brings up what your IP address. No. Yeah. Tells what your IP addresses are, and let's see. Guess I'm not 100% clear.
We're close, right? So ARP, if we look right there, we have really the ARP protocol, which you just ask, who has this IP address? Tell this IP address. And the response that you'll get from someone is, that IP address is that. What is that AABBCCDDEE? What does that look like to you? What do you think that's referencing, guys?
Your MAC address.
Exactly. So ARP is for resolving a IP address to a MAC address. Level 2 OSI way back when, we remember.
Right, trying not to get it confused with DNS. So.
Yeah, it's confusing, right? So this is what we're doing at level 2, right? We're mapping IP addresses to MAC addresses.
Okay.
So this is what's happening here. So essentially, if you want to find out who is on your network, you can send out ARP requests, like who has this IP address? Tell me. You send that out, and if someone has that IP address, they'll respond and give you the MAC address. There's a problem with this, and I won't be able to do this in PWK, though. Who knows why I cannot use NetDiscover and ARP to find hosts in PWK? Kind of trivial.
Is it because this can be poisoned?
Nope, ARP can be poisoned, but not. That is not why. Think OSI. Think layers. So the answer is, this is actually kind of a trick question, sometimes an interview question. I'll ask you another one later. ARP doesn't go over the VPN, right? ARP won't go across a router. You won't see that information there. So if this is my local network, I can do this. But I'm connected to a VPN, I have to go through that. And that ARP information, I won't be able to use this for PWK. So locally, this is great. For PWK, ARP is not going to work for me. It's at too low a protocol, too low a level on OSI. So we have something else. So let's try this. ICMP, right? We have the ICMP protocol, What does that do? It's also known as ping. We've used ping before. You can ping on the network and see how it responds. If it responds, it must be up. Right? Does this make sense? We can ping the machines on the network, and if it responds to me, it must be up. And I can do that over the VPN. What, and here's a trick question, I guess. What port does ICMP go over?
It's not 113, is it?
Nope.
No.
It doesn't go over any ports. It's not at that level. It's not at that level. ICMP is below, right? So we can ping them, but you don't give a port when you ping, right? You just ping an IP address. So let's try to find all of the IP addresses available to us in the PWK network. Okay. I'm going to help you guys out, get you guys started, give you guys a approach. Then we'll split up, I say 20 minutes maybe, in groups for you to try and make a list of all of the IP addresses we can find with ping on the PWK network. So let's get started. Let's figure out how we're going to actually do this. And I hope I don't have any secrets out here. Clear, clear. Okay, cool. So I'm connected to the lab network. Let me close that. I don't want to show you that yet. Okay. Cool. I'm just in my scrap directory. Okay. And I'm going to do IP-C adder. So I can see here, I have my ton 0. This is my IP address for the, that will be known to everything on PWK. Okay. So what do we know about the PWK network? What do we know about the network first? About any of the IP addresses on it? Do we have any idea of what the range or what the IP addresses look like? I think this may have been in the textbook.
Would it be like 10.11.1
That's what I'm looking for. I'm looking for that.
to like 255?
So the IP addresses for all of the PWK ones are 10.11.1.x. Something like that. So if we want to find out which ones are open, you just ping 10.11.1.1. And we'll ping that one. And it looks like we're not getting any kind of response. All right, look, 100% packet loss. All right, let's try 2. No dice. All right, let's try 3. What am I doing here, guys? Oh, that's taking a while. Let's try 4.
You're iterating over the range that we know.
Yes, exactly. Right. I'm doing like if you start doing things like this, you should be like, wait, maybe I should write a script to do this for me. All right, I want to keep going at least until I see one of them that responds to my pings. So I can confirm, hey, this does work. I'm not super crazy. At least one of these will respond to my pings. Okay, so that's the first start. I can ping them. And if it responds to my ping, I know 10.11.1.5, that is a live host on this network. What might I want to do to make this a little easier? Does anyone have any tips for me? Anything I might want to look through in ping that might make this easier? Do I want to keep pinging? How many times do I want to keep pinging? Looks like it pings 10 times by default. Do I need it to ping 10 times?
You can set a numerical value with the count with the -C.
That's right. So we can totally Google if we didn't know. We can only ping, we could make a ping that only sends one ping request, right? Instead of all of these over and over and over, right? So we could do ping. Let's do ping dash help. Let's see if we could find. There it is. Just what he was. Just what Dwayne was telling us. We could use the -C flag for the count. And it says stop after blank replies, right? So I'll want to stop after one reply. If you reply to me, you're up. Ping -C. We'll do 1, 10, 11, 1, 5. Cool. That seems a little bit better. I'll do it only one time. Okay. Anything else we might want to add? This is kind of good. It's not very nice formatting, right? We can do a couple of things so that we just get the IP address. But I think that this is maybe enough to get you started. So what I want you to do, I'm going to give 15 minutes with groups when I open up the breakout rooms, is to write a script. Let's do this. pinger.sh. We are going to, I'm just going to put this down here. Write a script which pings the 10.11.1.x /24 network and get a list of live hosts, or really just live IPs. I'm not going to have their host names yet. Do you have any questions on this or how you might go about approaching this? And does this seem like something you may be able to do in about 15 to 20 minutes with maybe like 3 minutes, 5 minutes talking about it with your partner?
Is this something you want us to do in Bash or?
It's probably easiest in Bash because you're going to use ping. So it's probably easiest to do it in Bash. All right. Okay. Do you guys feel confident? Maybe not confident, but I feel like you maybe can do this. Maybe can. All right. I just want you to write a script that pings every single one of these, and the tools, or at least the starting place I gave you was, we'll start somewhere with this. Ping-C1, and then 10.11.1.x. Okay, you know you're going to have something with this in there. Okay, I don't necessarily care how you do it or how it's formatted at this point. I just want you to try and get a bunch of IP addresses off of this network using ping. All right. So let me zoom recording, share screen, desktop 2. All right. So we're back and we're here, and our task was to write a script or really do something to find out all of the live hosts or hosts that respond to ping on the 10.11.1/1.1/24 subnet. So someone that did put their hand up, would they feel comfortable navigating for me? My water bottle. Come on, tell me how to do it. We were almost there already. I'll show you how I've approached this. So I know ping -C1 10.11.1.5 works, right? You can do this and we get this information back. I want to do this, but instead of doing it, I want this X value to change, right? So I'm going to put this inside some loop, right? I put this whole thing, this whole thing I need to put within a loop. Okay, so let's call this, instead of X, let's call it just, yeah, we'll call it X. But we know it's going to be a value in Bash, so I'm just going to call it value. $val. Okay. I know I'm going to put that in there. And I know I'm going to put this all in a loop. So we know how to write a loop right in bash. It is for, and I already called it value, so I'm going to call it value in, and to do a sequence, right? We do 1 to 255. Space thing. Okay. So for this value from 1 to 255, and essentially just do this same thing over and over, but replace this. Right. So let's see what else we have to do here. I think it's just this and done. Unexpected token near ping. What did I do wrong here? Let's try. Unexpected token near ping. Let's just do it this way.
Is it doping?
For val in 1 255. Actually, let me do this in a smaller range just so I don't get a whole giant amount of them. I'm just going to go from 5 to 15 or something. So we only do 10. Okay. Do, oh, I know why. I didn't have a do. I'm supposed to have a do block here. All right. Do, what do I want to do? Ping dash C 1 10.11.1 $sign value. Done. And you'll notice that it's going to do this, but I have to keep hitting Control C for every single one of them. It's like a little bit annoying. Does anyone remember the bash tip to throw things in the background? It's like a, I think Frank may have mentioned it way back. It's a special character. Ampersand,
Mentioned
right?
it this morning.
Oh, was it this? It was just this morning? It was way back. That's how way back it is. What am I doing wrong here? 5 to 15. Do I need this and? I could put this in parentheses. This should just be and, right? What am I doing wrong here, Frank? Should just be able
Put a
to put
space between the ampersand. Wait, no.
Oh, that's what I thought I had that.
Put in a semicolon after do. I mean, it's not necessary, but just let me see what happens.
Oh, okay. Oh, that shouldn't. Is it maybe because I don't have a space here after? That doesn't make sense. What's going on here? Clear this.
Do it on multiple lines.
All right. For val in 5 to 15, do ping dash C1 10.11.1 $sign value ampersand. Done. There we go. That's what I wanted. All right. So now I don't know what these come up with, what those IDs are, but you can see here which ones 10.11.1.10. Which ones return back to me? Did I just pick a bad range?
No, you have a typo. Go back. You did lowercase val.
That's right. There we go. That's what I'm looking for. 10.11.1.5 responds. 10.11.1.14 responds. 10.11.1.8 respond. So this is one way I can do it. Did anyone do it a different way? No? Did anyone Google? Did anyone just Google ping sweep scan? Yeah. See, the people that got it Googled it. You just Google ping sweep scan.
You
Let's
could
take a
also
look.
just look at your control panel because it tells you all the numbers.
Yes, you can just look at the control panel. But what if I'm on a network that doesn't give me a control panel, William? If I'm just jacking in right there, I don't know what's on that network, right? So I may have to do a ping sweep scan. You do ping sweep. You do bash. I think I Googled that before. I found this one before, which was kind of nice. I thought this one was cute because it's like pretty similar to what I was doing before. They ping their range, but they grep bytes from, so they get rid of a lot of noise. You can see there's the ampersand. I think that's the only difference in what they're doing. So let's just try that one. Clear. I want you guys to write your own, but I want to also see what other people have. So 10.11.1, not that. Run it. And there we go. That's kind of cute, but we can do better. We can save this as initial ping sweep text. Sure. And since we're going to do it for the whole range, let's do from 1 to 254. I don't have to go to 255. Why not? Why don't I go to 255? I thought they did the grep thing. I don't know. Oh, did I not copy this? That's what I wanted. Do that. Yeah, I think I grabbed the wrong thing. Here we go. 10.11.1.2. That. I want to save this to a file. Can I do that? Yeah. Initial ping sweep. There we go. So this is what I'm looking for. I have now this file that has all of the IP addresses that that responded to ping. What can I do to make the file a little bit nicer? I only want these IP addresses. Who's got some bash tricks for me? I don't want to have to open up this file and look and pull it out like that. How can I get just the IP addresses? What command do we know from way back in Foundations?
They don't have yeah, this is okay, so I believe it would be the TR command.
To translate? What do we want to translate?
I guess I don't know if they'd be doing too much, but I guess you would want to take out everything that surrounds the
We could do that. My approach would be, I see that these are all set up in a nice columns. I could split them up on the spaces with cut. And I can just grab the 1, 2, 3, 4th row. And then I can do something to remove this last character, right? I'll just Google how to remove last character bash or something, right? So cut -D for delimiter. I want to cut on spaces. So if I just type cut requires you to tell it then what field you want. So the way cut works, tell it what you want to cut on, and then you tell it what field you want. I want the 1, 2, 3, 4th field. I do that. Cool. Now I have just those. I Googled how to remove the last character because this is a, you'd kind of use awk or sed when you want to do some kind of like string manipulation like that. So I kind of Googled remove last character bash. Pretty sure I found a nice, there it is. Someone has an answer for me. They used this, and this removes the last character on a string. So I could just do that, pipe that. That wasn't the right one. I think it's dot that. There it is. And now, let's rewrite this file as a list of IP responded to, what a great file name right here. List of IPs that responded to ping. Put it all in there. Now I have a target list. Okay. Of course, I already had one before, right? As William showed us, of course, I can definitely look at each of these machines, but now I have a list of all of these machines that responded to pings. It's important that I keep clarifying or qualifying the statement that these all responded to pings because they don't have to. Machines do not have to respond to pings, but these did. You may find that not every machine on this, not every IP address here in my list is on these public servers. Some of them might not respond to ping. Okay, cool. Let's get back to where we were then. Any questions on before I do this? Any questions on what we did to get this list? Anyone in their own words explain to me what they did to get this list? That's the real question there. How did I get all of these IP addresses?
Used used the for loop in Bash in order to loop through all the different IP addresses, and you forward that into a list of you forwarded it into a command. You typed it into a command to get the fourth column of just IP addresses, and you put that into the folder with list of IP respondents.
Yeah. So the big takeaways were we used ICMP, we pinged all of the machines on the network, and just wrote down which ones responded. Right? Just like poked everything that could possibly be, right? Everything that could possibly be in this range. If you responded to me, I'm going to put you in this file. And now I know that you at least respond to pings. Okay. This is important. This is like the first step of mapping out the PWK network, right? What is actually on there? And so far, we have this. Very good. Very good. All right. We've discovered some hosts. Nmap is what's being introduced now. And Nmap's your new best friend. Nmap is fantastic. It's going to make your life, well, I won't say it makes your life easier. It makes your life possible, right? It's going to be doing a lot of things for you. First thing I want you to be aware of is just how much data these Nmap scans are going to do, how much traffic over the wires actually are going to be sent when we do Nmap. It's not going to be super important to us on this side as red teamers right now, where we don't care if we make a mess or if we're loud. We're just trying to break in. But on the blue team, we'll be aware of just exactly how much noise we're making as we do everything. If you are paying attention, right, you probably have seen on Offensive Security's website, they have that like, their motto is like the quieter you are, the more you can hear, something like that. This is what they're talking about, how loud we are when we're doing all of our attacks. We need to be aware of how long the scans we're using Nmap for take. Okay, some scans are going to take a long time. Some scans are going to be short. And we don't have a lot of time as we're working through this. We are constantly fighting against time, in fact. And so we need to constantly be working on several things at once. So you need to be aware of how long each scan is going to take, roughly, in terms of minutes to seconds to, longer than that. And what are you doing while that scan is happening? Because you're not just waiting for it. There's not enough time for you to just say, I'm going to run the scan. We're going to wait 10 minutes while it finishes. It's just not enough time. So to that end, we always start with the smallest scan and then expand, right? Smaller than bigger. We are not going to start with the biggest Nmap scan. There are tools I'll eventually show you that will automate a whole bunch of stuff, and that will give you a ton of reconnaissance information. But you'll get some kind of like sensory overload, and it's too much for you, right? It's too much for me if I just automatically just run like an auto recon script and get all this information. You got to start with the minimum scan and then expand. What is here? And then slowly look. Okay. So we can use Nmap for host discovery. We spent a good like 20-ish, 30-ish minutes right now struggling to write some bash to ping everything on. But Nmap's got some built-in stuff for us. And you can see right here, we can use Nmap and this -SN flag, which essentially is telling it to do a ping scan of that network, of the 10.11.1.network/24. So let's try it. We did it the hard way, the manual way. Let's try it with Nmap. So if I'm going to use Nmap, what's the first thing I'm going to do if I don't know how to do it? That. I'm always going to do that. And scroll to the top. It's going to tell me what you can do, right? So usage, you tell it what type of scan, you give it some options, you specify your target. Okay. You can pass it host names, you can pass it IP addresses, you can pass it networks. Seems pretty useful. For example, you want to scan me at nmap.org, you can scan that. You can scan Microsoft.com, the entire /24 network. You can scan this. A single IP address. You can scan a range of IP addresses. You can scan multiple ranges of IP address because you see this is 10, 0, 0 to 255, 1 to 254, right? You can take any of these types of targets. You can give it an input list, a file list, right? Just a list of IP addresses and have it scan all of those. We can have it exclude certain hosts. Cool. We can do host discovery. This is what we're interested in. And so ping scan is what we want. Ping scan. So let's see how we can use nmap to do what we just did. Nmap send 10.11.1.0/24. We're going to let that do its thing, because I'm pretty sure this should go quickly. A few seconds at least. There we go. There we go. Here's my return. And I have this list of them. That's kind of nice. I can clean it up a little bit because you see I get these two or three lines. Yeah, 2 lines for each one. I just want the IP address. Now that we know that works, let's just put that in nmap ping sweep. .txt. I'll just call it that. I'm just going to do what I did, save it to a file so I can manipulate it a bit more, so I can just get the IP addresses. And really all I'm doing is showing you how I can use nmap to do a ping sweep. Here's my nmap ping sweep. What do you think I can do, guys? Someone help me with some bash skills here. I want just the IP addresses. What can I do? What can I do with this file so I can get it so I get just IP addresses?
You can split it and get the last element.
Could, but you see, like I'm not really in Python right now. So think bash. Think how I can do this in bash. I'm gonna start with cat nmap ping sweep. What can I pipe it to filter out some stuff I don't want to see?
Could you use the cut command again?
I could use cut. So a way to think of cut is if you have a file where everything is kind of nicely in even columns. So this one has 1, 2, I don't know if this one will be a good idea for cut. I'll definitely use cut at some point, but you see I have 2 different kinds of lines each time. I've got this nmap scan report line, and then I've got this line saying host is up, and then this and that. So what can I do to remove some of this? You've done it before. I know you've all done it before. I know you've all done it Monday.
Can you slice off the second line?
That's what, I heard someone say it, and I heard, I think it was Michelle said, what doing, like you were both right there. I heard grep. What am I going to grep? What's the pattern I want to grep for so that I only get IP addresses? It's going to take
IP addresses.
Oh, okay.
Grab
Grep IP.
10.11.1, right? Can you do that? Can you grab the numbers?
Boom. Chris, thank you. I like that. Now that'll grab everything that has 10.11.1 online. Now we can pipe it to cut. Cut on spaces. Give me 1, 2, 3, 4, 5. Cool. Now I've got a list of IP addresses that I got from nmap. It should be identical to the ones I got from ping because they're both doing the same thing. But I do want to show you that you can use nmap to do that. And it's a little bit simpler, right? Just nmap-sn, give it the range. And then we can do some pretty easy just grep for what I want, right? We could even change this to grep for, if you want this more general. I think what do I usually do? You can do like is up, grep is, or grep up or something. Oops. Nope. Oh, the opposite of up. 4. All right, that'll do it too. Same idea. But that's what we're looking for, that pattern. I'm going to keep doing these kinds of like relatively simple, like a bash sort of exercises, tricks, because that's a lot of the job, is kind of manipulating certain things and using bash to make your life a bit easier. Okay, cool. So we have a list of IP addresses now.
Matt,
And we've, yep.
before you move on, can you show that one command that had the nmap that did the sweep rather than cutting it and putting it into a text
Yep.
file?
There it is. There it is.
Dash SN.
So dash SN. And if I didn't know, because I don't know a lot of things, dash L.
Yep.
And I would search for what I want, host discovery, ping scan. And we can see what it does. It says disable port scan. We're going to get to that. We're going to get to that. Let's take a look at some of our slides now. Cool.
And when you did the nmap, you didn't really have to specify the range. It kind of like already knew to.
Great question. So nmap, I want to see, does it say where the ranges are here? So you can specify the range in different ways. Nmap's pretty smart. You can give a dash if you want this range. So let's see how this is saying 10.0.0. And here, this place can be 0 to 255, and this can be 1 to 254. So you can use dash for ranges. You can do /24 if you want to use CIDR notation. So /24 is those last bits, these last bits, right? So you could use that notation, you could use that. You could use commas specifically too if you wanted to do like this. Nmap 10.11.1. Actually, I don't think you can use commas on it. So it'd be like that. Okay, cool. So we know how to use nmap to discover all of the hosts that are on there. And we know that it uses ping. And we know that we can use just the regular ping to do the same thing. Cool. Let's talk about what nmap does when nmap scans. So there's a few different types of scans that nmap can do. Let's talk about the main kind of scan that most the most common type of connection that clients will make. This is not the most common that nmap will make, but this is the most common that clients will make. And that's that 3-way handshake over TCP. So you send a SYN, you receive the SYN acknowledgement, and then you send the acknowledgement. Right? 3-way handshake, SYN, SYN-ACK, ACK. We've kind of seen this before. I'll show you again how nmap does this in Wireshark, so we could take a look at that too. There's another type of scan that nmap does, not called the TCP connect scan, but its default scan is instead called the TCP SYN scan, or sometimes you'll see it called the stealth scan. It's kind of a misnomer because it's not really extra stealthy. It was way back in the day, maybe. But as you can see here, we've not returned the acknowledgement. We've sent a SYN packet to the machine. We've received the SYN acknowledgement. We just don't send the acknowledgement. So this is how this scan will work. It'll go to the IP address. It'll knock on that port number, send a SYN, receive the SYN acknowledgement, just never send the acknowledgement back. We're just going to leave that server hanging. Which one of these scans do you think is faster? We'll compare.
Probably the second one.
Probably the second one. Why?
Just because it's not doing a third of the steps.
Yeah, it's not doing a third of the steps. This is the most common type of scan that we're going to be doing. It's called a TCP SYN scan. So the major difference is we don't send that final acknowledgement packet. This used to be known as stealthy because a lot of servers, their logs wouldn't report this as a connection if it was never fully established. So it's just kind of poking, but most logs, I think, will record this interaction now. So we got these two main types of scans, SYN scan, stealth scan. Okay, let's look at the main options we're going to be using with nmap. There are way more than this, but these are the common ones that we're going to be using, especially today and tomorrow. So we have the -P option to specify what port you want to scan. Okay, specifically, what port do you want to scan? We have -O for nmap to try its best to determine what operating system this machine is running on. We have the -SV flag to tell me and try and tell me what service and what version is running on a particular port, right? Because it's not enough just to know that a port is open. I need to know what's on it and hopefully what version's on it. There's this dash dash script equals. Dash dash script equals is so you can specify particular Nmap scripts. Nmap has its own scripting engine. And essentially, you could think of it as modules for Nmap that will do additional work for you that other people have written. So for example, if you find some machine and you think for some reason it might be vulnerable to some big exploit, there may be a script that you can run from Nmap that will check that machine if it's vulnerable to it and tell you. Okay, we have the -pn. Treat all hosts as if they're online. Why might this be useful?
If you want to be quiet so that they don't find you, then you know if people are online.
Not exactly. So what this is going to do, or the way Nmap will work first, is before we start scanning the ports, we're going to ping them. We're going to say, hey, are you awake? And if you're awake, then we'll start scanning the ports. Because like Nmap's trying to be smart, right? I don't want to make noise if no one's home, right? I don't want to go poke on it if no one's going to even answer the door. If you use the -pn flag, it's going to skip that ping step. And this might be important if some of the machines are set to not respond to ping, because they're supposed to be hidden. So we can ignore that step. This might be useful to you, and you'll definitely use this flag. I'll say that. There are machines that won't respond to ping. They'll be like, why aren't you, I know you're up. This is probably why. You're just going to use that. We can use Nmap to do a UDP scan. So if you remember, we have TCP ports, right, up to like 65,000 some odd. We also have that many UDP ports. So some services run over UDP, so we may need to check those UDP ports. UDP scans take a heck of a lot longer. So that's something that you're going to want to keep in mind if you're ever testing UDP ports. They take way longer. So you may want to get those scans started earlier if you have reason to believe there's something on there. And then you have the -a flag. This one's pretty common. I suggest you don't use it right away. It throws a whole bunch of other things in there. I think the -a stands for aggressive. But it does a whole bunch of things. So it'll enable OS detection. So it does your -o flag. It'll do your version detection. So your -sv. It'll throw basic scripts or the default scripts. And it'll throw traceroute in there too. I'm not actually sure if it's the default scripts or if it's the aggressive scripts. So we can check the man page on that together. But these are the common options we're going to be using with Nmap. Okay, so when do we use Nmap? Pretty much for everything. Nmap is going to be our eyes in this network, right? We can't see anything, but Nmap can see for us, right? We're going to check which machines are available with Nmap. We're going to check which ports are open with Nmap. We're going to enumerate those services on what versions are running on them with Nmap, right? We're going to determine what OS is running, or at least get some hints for what OS they're running, and other kinds of machine information we can get from Nmap. And we can also use it to run scripts and check if the machines are already vulnerable. You're not going to write any of these Nmap scripts yourself. We're just going to use some scripts that other people have written. And obviously, tons more we can do with this. Okay, I've been talking for quite a bit now. Let's take about 5 minutes. Did I stop recording? Okay. Yeah, let's take 5 minutes and we'll come back here and start talking about DNS enumeration. Let's take a look at actually using Nmap. So I have my my list of IPs that responded to ping. This is my target list right now. I want to learn about all of these machines. Okay, that's really the goal that we're going to be spending really almost every day here from now on till the end of Red Team, learning about each of these machines. You know, all of them are going to become our friends. And so we're going to use Nmap to learn about them. So the first thing I'm going to do is just pick one at random. I know which one I'm going to pick, 10.11.1.71. So this is what I'm going to do first with Nmap. Let me actually clear this. So this is at the top of my screen. 10.11.1.71. So we're going to run Nmap on this. We've picked a target. I've given it no additional options. And we'll let it run. And you can see it didn't take too long. Ran, and this is the general output of what Nmap looks like. Okay, so it tells you what version, nmap.org, and here's what I see. Firstly, it says not shown 998 closed ports. It tells me it gives me these 3 columns here. It tells me what port, what port, what number, and what protocol, TCP, the state that that port is in, as well as what services are running. All right, so this assumes that there's HTTP running on port 80 on this machine. It says there should be SSH running on port 22 on this machine. All right, let's try another one. Let's do 5. All right, and then let's try one of the other options as well. I want to show you guys those. The important ones are, let's try -O and -SV on this next one. Here we go. Right, nmap on .5. Here's what we get. It tells me 996 closed ports and what ports they have open. So it says here 135 and 139 are both open. 445 is open. 1025 is open. So it tells me this 996, and if I add these 4, I get 1,000. Are there 1,000 ports? Did this scan 1,000 ports? Did this scan 6,500 ports? 65,000? What did it do? Anyone have an idea? I didn't tell it what ports to scan. Cool. So what nmap does, by default, without giving it any ports, just like that, is that nmap is going to ping that machine, and it's going to try and do one of those stealth scans. So it's going to send the SYN, get the SYNAC, and determine what's going on the most common 1,000 ports. It's not the ports 1 to 1,001, but the most common 1,000 ports that people generally use. Let's take a look at what this looks like with Wireshark. Right, what exactly is going on here? So I'm going to just pop open Wireshark. I'm going to put the ton 0 as my adapter, and we're going to run this nmap scan. And we're going to watch what's going on here. And we know, I think that finished. I think the scan finished. Yep, it did. So let's stop recording and let's see what we got here. I'm just going to lower that a bit. Scroll to the top. A lot of stuff went through. Look at how much data we just produced from just that nmap scan, by the way. Kind of a lot of packets getting sent. Let's look at the top. What did nmap do? Let's find out what my IP address is first. 10.11 or 192.168.119.150. That's me. This was the destination IP address, right? That's what I chose as my target, 10.11.1.5. What's the first thing that happened? We sent that ping request. Hey, 10.11.1.5, you awake? 150, look, we send a SYN. Send an ACK. And then once we receive that reply, look at what's happening here. I wish I could see the port. Yeah, here it is. Here's the source port that's making the request, 64477. That's me. Here's the destination port. You see, I'm just sending requests, sending SYNs to a whole bunch of random ports here. Right, 143. You see the high ports, the 64,001, that's me. The lower ports, that's the target. So it's reaching out and poking out to each one of those things and seeing how it responds. Right, that's what nmap is doing. It's going to reach out to each one of these things and see how it responds to us. And based on that response, we can tell what is running on it. Okay, so let's take a look. Let's close this now and do some more stuff with nmap. I had another. Here it is. Cool. So look at what nmap did. We can specify ports. So say I wanted to see what it is on port 80 for 10.11.1. 71, I know it has a server on it, so I can specify a port, -P, check out what's going on port 80 for this machine. And now it only did port 80. Well, I could put Wireshark up to show you that as well. Okay, let's try one of these other flags to see what it looks like. I'll do -O and -SV. Just gonna run this up. In this case, I'm gonna do the top 1000 ports again. -O and -SV. So hopefully try and tell me what operating system this is running. Tell me what service version, what versions of services it's running. Okay, let that do its thing. Let's look. Any other of these flags I want to show you? I think that's about it for now. Maybe I'll do a -A. I'm going to leave that for you. But okay. I know how to use Nmap to scan for ports. What can I do with this information now, though? Like, what service is available on most networks that'll give me more information about the network? We'll look at this later. We'll come back. What service can I run? What service can I use to get more information about everything else? Who knows about everybody?
Google.
Google does, yes. But what specifically at Google? 3-letter thing.
DNS.
DNS, right? DNS knows about everybody. What we're doing now, this pinging and seeing who's awake, yeah, we can do that. But we can also ask the DNS servers, because the DNS servers know everybody, right? Because if the DNS doesn't know them, no one can find them. So let's take a look at how we might leverage DNS in this case. Okay, why is this up here? You go away. You go here. DNS enumeration. So we have a list of IP addresses. The next step is figuring out which one of these guys is the DNS server. Who's the DNS server on this network? Because once we find the DNS server, we can ask the DNS server for information about everybody. Right? You see the idea here? First, we'll find out who's even here, then find out of those that are here, which one of you is the DNS server. And once we know who the DNS server, we can ask for more information. So just refresh on DNS, right? It's just a database that maps out domain names and IP addresses. Okay? It's kind of similar to like what we had ARP, right? At that lower level, where we were mapping IP addresses to MAC addresses. Here we're mapping domain addresses to IP addresses, higher level. And so we have whois, which can get you some general information, right? We can throw whois on a domain name and get some general information that way. I'll show you that. We have our three tools, NSLOOKUP, dig, and host, right? We've used those already to query for DNS information. So we're going to be doing that again once we figure out who the DNS server is. And we have some automated DNS tools. DNS Recon, Fierce, I think there's a DNS enum or something like that. There's another one I know that's inside Kali that comes in. But these are automated scripts that are essentially going to be using dig, host, or NSLOOKUP to do that DNS enumeration. Let me move this over. So we have Nmap now. How can I tell with Nmap which one of these IP addresses, which one of these hosts is going to be the DNS server? What do we know about DNS? Or if I asked you about a web server, right? Maybe how would I use Nmap to find a web server? what do we think a DNS server is going to look like? That's a good question, right? We have to know what it's going to look like if we know how to find it. If I ask another question, I think it'll give it away. But we already know how to scan for ports. What do we know about DNS? Give me random facts.
DNSs have records.
They do have records, absolutely.
Oh, does DNS have a specific port?
Boom. DNS has a specific port. It's got a common port. It doesn't have to be on that port, of course, right? Nothing has to be anything. But there is a specific port that DNS is generally going to run on. Who knows what it is? If you don't know what it is, Google it really quickly for me.
Is it 53?
53.
It's 53. It's 53. So at this point, I'm going to give you, I want to say, I feel like 15 to 20 minutes is probably enough time to use Nmap with those, you have a range of IP addresses now. We know how to scan a particular port. I want you to find, or at least give me a list of which ones you think might be the DNS server. Okay, we're going to look for, from that list, which one is the DNS server. So let's before I split you out, let's think about some approaches. Okay, yeah, let's think about some approaches. So I have a list of IPs that responded to ping. I also can just, scan the whole network with Nmap. What am I going to look for? Which of these flags might help?
-P.
-P. All right, so stick it up. Nmap, -P. What port do I want?
53.
53. And then let's give it a range. So 10.11.1.1/24. Is there anything else I want to do with this? I'll do. Yeah, that should be fine. All right, so we'll let that run. It's going. Nmap is going to. I should have had Wireshark going so we can look at that too. But here we go. We have and this is not the best format, but it scanned all of those things, and of the ones that responded to ping, you get this information. So let's look at this. Let's look very carefully and closely. So here, Nmap scan report for 10.11.1.5. It says it's up, and here's the information about it. 53 closed DNS, right, saying domain. Do we think this 10.11.1.5? Do we think that this is it? And if not, why?
Probably not, because if it's closed, then other addresses can't access it.
There you go. There you go. It's closed, guys. Nothing. Pool's closed. Can't go. All right. Nothing here. 10.11.1.5. Probably not the DNS server. We look at this one. We check this one. 10.11.1.8. We notice here we have a slightly different state. Right. This one says it's filtered. There's something preventing all sorts of traffic from going through here. That's all I can tell about that right now. So .8, maybe. Right? We can go through and filter out closed, etc. The other ones that you might be interested in are ones that say open. Right? Open's kind of nice. You might want to look for those. So there's 3 states for them, by the way, so you don't get confused. There's closed, there's filtered, which usually means there's some kind of firewall, and then there's open, which means open for complete communication. I think at this point, that is enough to get you started. I'm going to give about, one more thing. Once you think you have the DNS server, once you think you've narrowed it down and you know which one of these is the DNS server, how can you check it? How can I check?
You ping it?
We can ping it, but that might not tell me, right? That ping will, like, let's say 10.11.1.5. We don't think it is, but ping, 10.11.1.5 still responds to pings. Well, what tools do we know?
Can you do a reverse DNS lookup on it?
You are very close to where I want to be. Yes, essentially, not yes, but we can use dig host or NSLookup to test, right? I can do host 10.11.1.5 or 5. And let's say I think 10.11.1.71 is the DNS server, right? So this is doing a reverse lookup. This is actually, yeah, you're absolutely right. This is doing a reverse lookup. Like, look up what is the domain name of this guy, ask this, and we can try it. And I'm waiting. I'm pretty sure it responds. Yeah. 10.11.1.71 does not seem to be our target. Does not seem to be the DNS server because it's not responding to us. It's not giving us the information. All right. So your task will give you about 20 minutes. I think that's reasonable. Is to use this IP list, narrow it down, figure out which ones you think are going to be the DNS server, and then test them using host or dig or NSLookup, right? If it is the name server, I'm obviously not going to give it away. You won't get this. It'll just give you a response. It'll tell you what the host name is, what the domain name is. Okay.
I have a question.
Yes.
Where are you getting the 0.5 and then the 0.71 from?
Oh, 0.5 I just picked. 0.71 I just picked. I was saying if I wanted to test if 71 is the name server, this is how I would do it. This is just a random one I picked. I know it's on that network. So like, give me the domain name, give me the host name of this guy, asking this guy, right? Just like how we did host before. Yeah, this is how we use host before. Like when we do, actually, you do it here. Like host google.com. I think you could do it like that, right? It's doing the same thing as this, essentially. Kind of.
Okay.
But you're doing it with these, right? So tell me what information you have. This guy. So here's what you're doing. Use Nmap. Narrow down that list of IP addresses. Once you have it down and you think you know which ones may be a good list of candidates for the DNS servers, test them out. Find out where is the DNS server on this network. Questions before we split up?
Yes. Can you put the bash code for the original list of IPs in Slack or something?
Yep, I'll do that, and I'll give you the Nmap. I'll give you what I ran for Nmap as well. All right, I'm going to switch you guys up now. We'll be back at 4:20 to figure out which one of these is the DNS server. Who's the DNS? So who thinks they know what the DNS server is, or what IP address is the DNS server? Anyone? Oh, need some hands. What is it? Need some guesses. Some educated guesses.
Is it 220?
Is 220. Does anyone else get 220? There's actually two. But one at least that you'll find easily. 220 is the one you'll find easily. How do we find 220? You tell us, Chris. You navigate.
Yeah, I didn't do anything terribly fancy. I used the command that you described earlier, which was using the flag on Nmap to find specific ports, -P53, and we got that long list. And I just kind of relied a little bit on what I remembered from the Professor Messer videos and foundations, and that the DNS server would be open, and then the firewalls, which you described earlier, would be filtered. That'd be behind the DNS. And I only found 3 that were open, which were all 20s, 20, 120, and 220. And I got a resolution Alice Think Local from 220, and I did not get anything resolved from the other 2.
That's fantastic. That is exactly the experience that I wanted you to have. Oh my gosh, fantastic! I'm amazing. You're amazing. We're all amazing here. Let's do this, right? Nmap-p. Oh, let me share my screen. I got too excited. All right, so we'll do exactly what he said. Nmap-p. We're checking out port 53. We are taking a look at the 10.11.1.0/24 network. I am going to give another flag that was not on the that list. This -OG, you can look it up. It's for output greppable. I want this to output to a greppable format, so I can use grep on it. You can use grep on it anyway, but it makes it a little easier. So I'll show you what both forms look like, just so you can see, because sometimes you want a greppable form. So I did this, and I called it, let's see what I called it. I'm not going to run it again because it takes a little bit of time. I called it looking for DNS. So am I looking for DNS? I literally ran the command nmap-p53 OG looking for DNS. This is what it gives me. You'll notice it's the same information, but instead of putting it everything for the same host on different lines, they put a slash. So that way I can get everything from the same host. So I can do, because grep up, oops. Grep open, not up, right? Because we're looking for only the open ports. And these are the 3 that Chris said he found, right? 20, 120, 220. This is enough that I would manually try it, right? So he probably just did host 10.11.1.5, 10.11.1, 10.11.1.20, 120, and 220. The 20 and the 120 did not work, obviously, but the 220 did. And you get a result. We now have a host name for 10.11.1.5. 10.11.1.5 is alice.think.local. Okay.
You did only /24. How did you end up with 220? Mine only came back to 24.
What do you mean grep / so you ran?
So when I ran, I did nmap-p53 10.11.1.0. Yeah, I did 0/24.
It shouldn't matter. It should get all the same.
But it only went up to 1.24.
Testing for slow-mo. I will run this and we'll see. Should be exactly the same because it's the same command I ran. I'll let that run and then we'll compare. But now we have an IP address, or excuse me, we have, I should have made this greppable. Oh, no. Cat testing for slow-mo, grep open. Oh, still got those 3. I don't know. You did something wrong, maybe. Check through your command history and see, because you should get everything you should get everything from 1 to 255 on these final bits. Okay. So we have an idea about the DNS server, right? We can ask now manually 10.11.1, you know, 5, or let's do 71, 10.11.1.220, right? And then we can get this one. So 71 is named alpha.think.local. And we can do this for each member of that list. For every IP address that we've finally taken, we can now ask the DNS server, hey, what are their names? We can get them all that way. We can manually do it. We can also write a script that pretty much does the same thing, right? We would just wrap host 10.11.1.x 10 with 10.11.1.220, right? We'd pretty much just run that in a loop, throw that in a file and save it, and then we'll get all of these. Okay, so those are the two ways. That is one way we can get all of the domain names, right? We're enumerating here. We're getting more information. We started from nothing. Now we have a list of IP addresses, and we have a way to get the domain names. And we figured out who the DNS server is. Go ahead. I heard a question.
Where did the 71 come from?
71, I just picked one.
Oh,
I just picked one from the list. I just know 71, but it could be anyone, right? I could do 5. I can do 10. I don't know. Is 10 one of them? I think 10 is one of them.
So
We
let's
can
say
find out all their names.
if
10
we're
is
just
Mike.
testing a random IP address.
Yeah,
Like,
absolutely.
Yeah. In that case, we're just testing random IP addresses from our list.
Yeah, I was just testing. Like, this is just a random one. I just picked it. I was like, hey, what's this guy's name? Oh, his Mike. I wasn't doing any planning. I was just seeing.
And when you do the nmap command, is you just finish if you want it to go into a file, you just finish with a file name? Because I didn't, when you did.
Yes. Great question. So nmap has 3 different ways, 4 really, of saving to a file. Because obviously this sounds like something you'd want to do. You don't want to have to keep running nmap over and over again. You probably want to run it only a few times. So there's a few ways you can do it. Let's actually go through those. Make dir nmap scrap. Okay, so 3 ways we can do it. One way we already know, nmap 10.11.1.71. You know, using redirection. Okay, you do that. This will save the output to another file. Okay, the other way to do that is there's 3 output types. OG for output greppable. And this will give you that greppable form, which is really useful. Like I showed you, it'll put things on the same line. OG, I think OX, O something produces XML if you want an XML format for some reason. And I think there's one more format.
It's OX.
OX for XML.
Yep.
And there's one more, isn't there?
ON.
ON?
Yeah.
What is that way?
That's the plain text, the plain
right.
nmap output.
Plain nmap output. And I think, is OA output all? You can do get all forms if you want. So there's just different ways you can save the output. Absolutely. You can do it any way that you want, either by using the redirection or this dash lowercase o and another, let's say dash OA for all, dash O uppercase G for a greppable format, and dash ON for, I guess, plain text. So different ways you can save it. And you'll notice I end up saving like a whole bunch of files, some of them with crappy names. You'll do the same thing. You'll see what's good. Cool. All right. So let's get here. That's not what I want. I want to talk about more DNS enumeration. So what we've been doing is asking the DNS server, hey, we have this IP address. We know he's awake. What's his domain name? What's the host name of it? And we can do that manually. But there is something else we can do. All right, let me go to this. Zone transfers. Okay. Am I filming? Let's film if I'm not. Why am I not? There we go. Cool. All right. So what is DNS zone transfer? So obviously, guys, DNS is pretty important. If DNS goes down, all of our S is effed up. right? Everything depends on DNS because you don't know how to get anywhere unless you have DNS. So to that end, we need to make DNS highly available. If you remember, I'm trying to think how many weeks ago this was. There was something went down with Cloudflare, and like half the internet went down for a little while, a few hours. I'm pretty sure that was a DNS issue. So DNS is super critical because as DNS goes down, everything is kind of broken. So we need to make it super available. And in order to make it super available, we add redundancy, right? We add that availability. This is like that third leg of the CIA triad, the availability part, right? That's our job, making sure that DNS stays up. So in order to do that, we need backup servers. In order for there to be backup servers, there needs to be some way that the backup server can get all of the information that the main server has. There needs to be some function for this to work. Does this make sense so far? Right? DNS is important. We want it to always be up. There must be a way for there to be backups, to make backups of this, so that if something goes down, we have a backup DNS server. No problem. Right? There's a special function in DNS called a zone transfer. And what that does is it replicates the DNS database so that you can copy it over to another DNS server. And this is normally harmless and a feature that is great. Keeps things running. But there are misconfigurations, and sometimes anyone can just go ahead and ask for all of your information, and the DNS will just give it to you. Okay, this is a zone transfer. And we should get some different information than when we manually did this, right? We were manually checking, hey, who responded to pings? And then using that information, hey, DNS server, what's their name? Now, we're going to directly ask the DNS server for everything it's got. We're essentially getting the map of the entire kingdom when we get this, right? We're going to know who knows what. You would think that this is something that is really tightly configured, but I definitely know of, and if you listen to some Darknet Diaries, you'll definitely hear of this too. But there's definitely pen testers that have worked for clients that are large and should definitely know better, like more than 500 million in revenue clients, and they've found DNS servers that allow zone transfers and expose thousands, hundreds of subdomains and domains and everything else owned by the company. And some of those domains that are exposed might also allow zone transfers. So seriously, something to be cognizant of, and us as hackers, something we should always check. So how do we do a DNS zone transfer? We know what it is, generally benign, and it can reveal a whole bunch of information, right? It's the map of the castle. It's really the map of the entire kingdom, right? We're going to know everything if we get this. So how do we do it? You retrieve the name servers from the domain host. So host-t-ns on a domain. Okay, seems easy. I've done that before. Once you have a name server, give it as an argument and ask it nicely. So, right, host-t AXFR for domain transfer, XFR. And you throw in the domain and you tell it what name server you're going to use. So let's do it. Let's see. Host-t, let's check out. -t, we're going to look for. Uh-oh. I died. My VM. Here we go. Host-t, name server. Let's do google.com. Google.com has these 4 name servers for their DNS. All right. So let me look back at my notes, and it says host-t AXFR, give it the domain, google.com. Or yeah, the domain, google.com, and the name server. All right, let's try it out. Host-t, or -t AXFR, google.com, and let's try one of these name servers. Transfer failed. Seems like Google has their stuff put together. They're not letting me do a domain transfer. All right, let's try NS2. We can try all of them just in case. But no, transfer failed. Not letting me do it. No dice here. But you could guess I'm alluding to you can do a domain transfer with the DNS server that we found. Okay. So what do we need to do a domain transfer off of the domain we found? Well, let's look at the notes I had here. Host-t, the name server. Well, I need to know what the domain is. All right, before I just put in google.com. There's a google.com domain. I don't have a domain necessarily for this right now. Or at least I don't know what it is. Let's look for some patterns. I'm going to use host. Let's see, 10.11.1.5, 10.11.1.220. Okay, what do we get here? Alice, think.local. Interesting, interesting. Let's open up another terminal. Actually, I'm going to want these side by side so I can show you. Let's put like that. And I'm just going to cat the nmap ping sweep. Did I clean that? Cat nmap ping sweep. That's not as nice. I want just the IP addresses. So grep. What does it have on here? Grep 4. All right, that's fine. So what I could do is try and look for a pattern here. Right? I know 10.11.1.5 is alice.think.local. So let's try out the next one down the list. I'm actually going to go the list reverse order. So let's try 252. All right, this is fwdev.think.local. Okay, let's do 251. For fwit, think.local. Let me know when we see a pattern. Did I do this one wrong? 250?
Everything's on think.local.
I think we might have a domain name then. Think.local. Let's try one more just to see. Humble.think.local. So we see a pattern here, right? This domain is probably, all of these are off of the think.local domain, right? Just like how cyberlab.fullstackacademy.com is off of the fullstackacademy.com domain name. All of these guys are off of the think.local domain name. All right, cool. Let's try it. Let's see if that'll do it for us. Let me close this. All right, so I'm just going to reference my notes because I can't remember anything. Host-t AXFR domain name server. Host-t AXFR think.local 10.11.1.220. Let me make this a little smaller. But here we go. There's another flag we can use with host that I think we'll change it slightly. Host-help. And boom. This is what we want. We can use this flag too. Instead of requesting a type, -L. List all hosts in a domain using AXFR. Sounds like what I want. Think.local 10.11.1.220. There we go, cleans it up a little bit. So what I have here now is almost all of, if some people may have seen something else, but pretty much here have IP addresses and domain names for everything that's on this. Okay, there's one thing I don't think I've shown you, and that is, or let's actually show you like this. If I do this again, I want to see exactly how many are on this. Let's see, 1, 2, 3, 4, 5. So if I just pipe this to work dash, right? So it should be 5 less than this. That's how many I have here, right? I'm just counting up how many of these lines there are. -5 because of these. That doesn't look like the right number, right? Let's test it. Cat, did I do nmap ping sweep? Is that clean? I should clean that one up. Grep up or grep 4. And yes, these numbers don't match up. Something's missing. Something's missing here. All right, because here I have this many. So there's some that are on here that are not on the other list. I'm trying to find which one without giving it away. Did anyone find, while doing their reverse lookups, 10.11.1. something, where one of them did not report with something.think.local? No? Well, we could run a script and do it manually, right? We could do a host. Let me think about how I would do it. I'd pretty much just wrap everything in another for loop, right? How would I do this? Host 10.11.1. Dot something, right? So this will be some value, and then this will be 10.11.1.220. I want to run this inside some kind of loop, right? Let me do this on multiple lines. For val in on the 255. I'm being lazy here instead of just using the list and cleaning it up. What do I want to do? Host 10.11.1 $value 10.11.1.220 and this script is terrible. It's going to take a while. All right, done. Ruby. Did I do something wrong here? Oh, no, it is doing it. But it's also doing every single one, so it's showing you these not found ones. But I want to see if we can quickly pull one that's not think.local, because I know there is one that's not think.local. There it is. Here's one. And you'd only see this if you did this with all of them and we're paying close attention. Here's another domain we have here. Acme.local. Right? So let's do the same thing. You host. Let's see. We'll look it up again. -T, AXFR, domain name server, or -L. Acme.local. 10.11.1.220. Boom. There's the other ones we were missing. Cool. Cool. Questions on domain transfers, comments on domain transfers. Did I lose you? Did you get found somewhere? What's going on? Do we need to take a step back, look at where we're at again, think of what we did?
So does that mean that in this network there are 2 DNSs?
So there are 2 DNS servers, but this is not because of that. There are 2 domains. There are 2 domains here. We have the think.local domain, and we have the acme.local domain. That is what that means. So what did we do today before, just so that we have an understanding of where we're at, where we came from? Okay, started with passive recon, right? Not talking to anybody, not talking to the target specifically. Moved over in the afternoon to active recon. How did we do that? First, finding out who is on the network. We have two different ways of using ARP if we're right there close locally, not over a VPN or between a router between us. And since we do have a router between us, since we are using VPN, right, we're going to use ping, ICMP, to find out who is awake, who is on this network, right? That's what we did first. We pinged everybody on the network and wrote down who responded. Once we did that, we used the tool called Nmap to do some port scanning and fingerprinting. Essentially, we went over to each of those machines and checked for port 53 being open. So we can limit it down and say, hey, we're trying to find our DNS server. DNS servers have port 53 open. Let's look for those. We used host to test, all right? We used host to test if it was a DNS server just by doing a standard query. Hey, do a reverse lookup on this IP address. And we got some domain names that way, or host names really that way. Once we did that, we tried to do a domain transfer and we were successful. We were able to get the entire keys to the kingdom. And I encourage you guys, once I give you some time, to do what I have done. So, right, host-l think.local 10.11.1.220. Do this, save this to a file, right? This is your master map right now of the network. We did not have this before. We only had IP addresses. Now we have names. Some of those names might be useful to us, right? Some of those names, not so much. But we're going to refer to, from pretty much now on, all of these machines by their host names. Or at least Frank and I and fellows will. So we won't be calling them like .251. We'll say FWIT, or we'll talk about Ghost, or we'll talk about Hotline, right? We're not going to talk about them by number anymore because we're people. Cool. Does anyone have any other questions before we kind of move on from domain transfers?
Yep. Sorry, how did you get to Acme?
How did I get to Acme? So what I did was I searched, I did a reverse lookup on every DNS, on every IP address. And some of them came back with Acme. Yeah, so a reverse lookup on some of these IP addresses returned either think.local, something.think.local, or something.acme.local. That's how I found it. I found it by enumerating, right? All of this enumerating thing, like this counting, this is what we're doing. We're just gonna like go through everything and write down notes. The only reason you would have been able to find alpha.local is if you did a reverse DNS lookup on the ones that happen to be alpha.local. Right? So the whole process is like, you have to be very thorough with everything or you'll miss stuff.
How did you get the name server? Or is it just like the 10.11.1.220?
Yeah, so that's its name, 10.11.1.220. That is its IP address for the name server. We can also do a reverse lookup on it, host 10.11.1.220, 10.11.1.220. So its name is master.think.local. Cool. Cool. We can look up all of the other ones too. I encourage you to essentially just write a script that does this, right? Or just look at the domain transfer, the zone transfer. If we were not able to get a zone transfer, then we would have had to do this manually and just rely on whatever the DNS gives us. But it gave us a zone transfer, so we're going to use that. Okay. Cool. So how to do it? You'll do it on your own. So there's a couple of scripts that are on Kali. I'm not going to go through them. You can use them on your own. Since these are DNS scripts, you are allowed to use them on public networks. So you can go ahead and throw fierce at Google if you want. Or DNS enum or DNS recon. They all work very similarly. I think DNS recon is actually written in Python, but I could be wrong. But these all work very similarly in that they will do essentially what we've done today, but kind of automatically. So it'll attempt to do zone transfers. It'll attempt to look up host names and all that sorts of stuff. But it's important that we do things manually so we see how these things work. Otherwise, you'll do it and it doesn't work and you'll be like, I don't know. Yeah, do it manually. So these are the 3 tools I want to just show you. I'm not going to actually use them, and we probably won't be using them very much in PWK because we kind of have a lot of the DNS information now. We were able to get the keys to the kingdom, essentially. Okay. So FYI, I'm going to go through quite a bit of enumeration that we're not going to touch until tomorrow or later in the week. So it's mostly just to have as a reference that we'll come look back to. So we'll look back at these notes. So SNMP enumeration, going to run through these quickly. Right, so what do we know about SNMP? It's the simple network manager protocol. 3 main components to it. We have the managed device, the agent and network management system. Cool, what does all this actually mean for me? Well, it's UDP based, so I know I got to be looking for a UDP port if I'm doing this with Nmap. We don't often look at it quite as much because we're always focused on TCP services, right? TCP is exciting to us. It's like, you know, much faster, right? We're familiar with it more. We like it. It's not like drinking water out of a water bottle and spilling it all over your face, right? So it is something to be aware of. It has this MIB system, this management information base, kind of like a database, for information. Terms you want to be familiar with. It has this thing called a community string, which is kind of like a public password. Sometimes they're just empty. These things look like trees, right? You'll notice that almost everything looks like trees in computer science, right? Starting from the root at top, you have these upside down trees. So let's take a look at what you actually do to enumerate this. So those MIB values correspond to params. So do I have the values here? Oh, I thought I had a tree with the values on them. Certain values are going to map over to parameters. What does this mean for us? Well, we're going to be using 2 tools for enumerating SNMP. Most of this will be kind of automated, and we're just going to be looking through the information it provides us and kind of Googling from there. Oh, look, I do have those values. Right, so these values on the left, those like random numbers, are associated with parameters so that we can look things up on. So we can look up user accounts, look up storage units, look up all that sorts of stuff if you know what the MIB values are. Do I have to memorize it? No. We're going to use these 2 tools, the 161 and SNMP walk, to actually do it. So what does it look like? SNMP walk, or 161, is going to brute force. So it's going to like find what the community string is and then try and connect. SNMP walk, very similar. I think once you have the community string, you just essentially query the SNMP for more information. And to use these, you do -- help, essentially. It's just going to throw a big wall of text at you that you'll look at. Okay, so that's one service down. SMB enumeration. This one's pretty interesting and pretty exciting to me. There's a lot of history in SMB. A lot of pretty famous cyber weapons are kind of like based off of attacks on SMB. So what is SMB, or Samba? It's the server message block, right? It's a file sharing protocol. Essentially, there's files, people can share them. Here's the problem with it. It's kind of complicated and it's not consistent. And that is, if you hear things like that, as a hacker, you're like, oh man, there must be exploits, right? Something complicated, it's not consistent, someone's doing something wrong and I'm gonna take advantage of it. And that's really what happened with a lot of SMB. We can look at some specific attacks and weapons based on SMB. We'll do that. So it's a great attack vector. You see SMB or Samba open, you're like, this is a low-hanging fruit. This is interesting to me. I want to Google more about this particular version that it has on it, right? You see SMB, your eyes light up. So here, super famous, 2017, I think. Is that that's Eternal Blue, right? You there, Frank? You know it's Eternal Blue. Someone knows it's Eternal Blue. I'll look it up. MS CVE 2017 0143. Is that it? Yeah, let me grab this and show you. Right, this vulnerability specifically, I'm just looking it up off of the CVE list. I'll show you guys how to read these. You can see exactly what version causes this. We can look at when this was created. This is not exactly what I want to show you. I want to show you the famous one. Ah, there it is. Remote code execution vulnerability. When you see this, this is good for you, right? This means I can execute commands on someone else's machine. And if I can execute commands, maybe I could get myself a shell and execute more commands. So I forget what year it was that this came out. This vulnerability was exposed. I'm pretty sure this was one that the NSA, that was leaked. And it was like something like 40% of Windows machines were vulnerable to this at this time. Like you could literally root those machines from the other side of the world. So big stuff there, something to pay attention to. You see SMB, your eyes should light up at least a little bit. Okay, I'll post a link to that blog to the MS08067. I think that's the actual one I want to show you. All right, practical, what does that look like? Well, you can do null sessions with this tool called RPC client. Essentially, you do RPC client -u. You give it no string, right? You see that empty string right there. And what is the IP address of the machine you want to connect to? And from there, you get an RPC client menu. You'll see at the bottom. And you can query the RPC client for information. So the information you're looking for here are users, shares, what types of files are on there, all that stuff. You can do it manually. Additionally, there are scripts for SMB, for enumerating SMB. We have Nmap scripts. This is probably my favorite thing when I see SMB running. I usually run that second one right there. -P for 139.445. You can notice I'm doing a comma there, so I'm picking those two specific ports. And here, I'm throwing in that -- script. That -- script, I'm saying, hey, run the SMB vulnerability star. So run every script that starts with SMB-vuln on my target IP. Right, so I'll run that if I see SMB running. And what that will do is Nmap has a bunch of scripts that will check to see if there's a vulnerability available. And then it'll let me know. If it's available, whoop-de-doo, right? We can do something maybe. enum for Linux is another SMB tool. This one is automated, and you can think of it as something like that wraps around SMB client and RPC client and some of the other tools as well. You essentially run enum for Linux, give it an IP address, and let it run. It'll give you information that way. Questions on SMB enumeration real fast? I know we kind of just like jumped through it, and we're not going to get to do some practical stuff with it for a day or two. But you can always reference these notes. Cool. All right. Web servers. This we'll actually get to do some practice with today. And this is a big one, and it's probably my most favorite vector of attack, probably just because of my experience in web development. So it's the most common vector, right? Web's everything, at least these days, right? It can be found on all kinds of devices. Your router is running a web server if you connect to it, right? You probably have seen that before if you had to change certain features. So all sorts of devices are running web servers, and if we can crack into that web server, maybe we can do some stuff, right? So it's a big surface area for attack. And most web servers you're going to find are running either Apache or Microsoft IIS. These are the two that you're going to see most often. I'm pretty sure everything in PWK is. That is not true. That is not true. You'll see these most often, but there are more. And when you find them, you're just going to have to look them up. So here's what we're going to be doing with web servers. We are going to look for vulnerabilities so that we can get command execution on the host, right? Anytime I see that RCE, that remote command execution, that's what I'm looking for, right? That is my ticket. That says I can give commands to this machine and it'll run them. I might have to format those commands in such a way, but that's what I need to do, right? So the other types of attacks I'll look for on a web server, though, are they leaking information that they should not be, right? Are there files that are being leaked? And will it let me search for other files? Like, can I get the Etsy password from the web server, right? Can I get the machine's Etsy password file from the web server? Will it show it to me, right? Because if I have that, I can use another tool to kind of crack those passwords, and now I have passwords and user accounts. Okay. So let's talk about web enumeration, because web enumeration is huge. And it's the main point of entry. It's very likely to be in the main point of entry. If you see a web server, this is going to be where you say, oh, this is where I should look first. And that would be a reasonable thing to do. Okay. Usually you'll see them running on port 80. In PWK, that doesn't always have to be the case. In real life, it doesn't have to always be the case, right? But usually we'll see them running on 80. If it's running HTTPS, so it has the encryption layer, it'll be on 443. But usually we'll see it on port 80. We can enumerate and look at different paths by using these tools called dirbuster, gobuster, Derby. I don't know if Nikto actually does. I don't use it for that, but maybe you can use Nikto for that as well. So I want to find out everything that's available on the website. We've done stuff like this before, right? But now we're going to actually use a tool to automate doing it for us. So here's the idea. We have response codes, right? We do HTTP response codes. Every request we make, we get a response code back. If it's 200, it means cool, you can go there. If it's 403, it says, well, the server doesn't want us to go there. If it's 500, we broke the server somehow. These are interesting errors to us. If it's from 404, I don't care about those generally. Okay. So we know how to make requests. We know how to look at the responses. We're going to kind of use a tool that's going to automate this whole process for us so we can find out everything that's on the web server. Okay. So here's how it looks. We use Nikto first. Nikto is really easy. I recommend if you see a web server, you can throw it and then let it sit in the background. It takes a lot of time to get things done with Nikto. It's a long scanning tool. It's not one you want to be waiting for. To use, very easy, Nikto-H, give it a target. There are more options. This is generally fine. Derby is a web content scanner. This is similar to the tool that I was just talking about before. It's going to make requests to the URL host, and you're going to give it a word list. And it's going to make a request to the URL target host / the first word in the word list, and then / the next word in the word list, and / the next word in the word list. And based on the response, you know what happens. If you got a 200, all right, cool, we could go there. Get a 404, no luck, we can't go there, nothing there. And based on those responses, we can get information. Dirbuster is just the GUI version of Derby. I don't use it as often, but you can totally use it if you like. I'll show you both ways. WordPress scan is a vulnerability scanner for WordPress. Is anyone familiar with WordPress? Has anyone ever used WordPress before? Heard of WordPress?
Yeah, I've used it before.
Just a little bit.
Yeah, okay, so people have used WordPress. It's an app to build blogs and stuff like that, right? It's pretty common. If you don't know how to code or build a website, anyone can do it. And WordPress scan or WP scan is a popular tool that we can use if we see a web server running WordPress to look for particular vulnerabilities. I bring this one up because WordPress is super popular. I want to say, so I can't give a percentage, but many sites, many personal sites and private sites use WordPress to actually manage putting the content on there. All right. So we have GoBuster, Dirbuster, Nikto, Burp Suite, curl, your eyes and thoughts. These are what we're going to be using specifically for web enumeration. I didn't actually show you Burp. I'll show you that. Let's go through all of these. We'll do Derby first. So let's get there. I need to find a machine that has a web server running on it. Does anyone have one offhand? Or one of the fellows give me one real quick? I forget which has.
91.
91?
Do alpha.
Oh, yeah, 71's alpha. Duh. All right. So let's do first nmap -sv to get the versions. 10.11. Okay, 11.1.71. We're going to run that real fast just to confirm that it has a web server running on it. And you can see now why I always like having several things going on while I wait for my scan. How long? How long? Almost. There we go. Cool. Confirmation. 22 is open. Has SSH. 80 is open. Says HTTP. Can't confirm the version. Has some trouble here. Thinks it's Linux. Cool. I see these two ports open off of my first scan. And what I'm thinking in my brain is, where do I want to go next? What is the low-hanging fruit when I see these two things open?
Is it SSH?
No, not SSH.
Oh.
HTTP, right? HTTP. It's not going to be SSH because so HTTP is going to be the low-hanging protocol. We're gonna usually reach out to HTTP. SSH is old and super secure. This is like I want you to eventually be seeing. You see this? You see like a bolted down door, and you see like a fence, right? Bolted down door, SSH. This is old. This version's kind of new, I think. HTTP. I know HTTP has tons of vulnerabilities. I'm not even going to look at SSH for a little bit. I'm going to say HTTP, this is what I want to enumerate next. And this is how we're going to be thinking when we're attacking every single box. You're going to do the basic Nmap scan and say, which one of these is going to be the easiest for me to start looking into? And sometimes you'll be right and sometimes you won't, but this is the approach. This is how you always want to be thinking about it. And if I see SSH, generally not going to go that way. I could try some kind of SSH brute force attack. You know, I could try some kinds of attacks that way, but we're not going to go that way. Yeah, we're going to see HTTP port 80. It's open. All right. So what can I do to enumerate this port now? I showed you some tools, but what do you already know how to do? What do we already know? With the webs? Sorry? You see a web server. What do you want to do with it?
Curl.
Sorry?
Could we use curl?
We can use curl, sure. Curl 10.11.1.71. I'm pretty sure I have to give it a port 80. You have to do it like this? I forget. No. Nothing. So use curl. You just go to it. We can check it out. Right? This is what I would do. I see a web server. Let's check it out. See how it's supposed to be seen in a browser. Let's see what happens. Right? So cool. I've found the site. This is at this point, I would maybe start doing some semi-passive reconnaissance, right? I'd look around at what I got here. I'd look at this contact information. That's interesting, right? Maybe I'd Google that. I'd start playing around with what do we got here, right? I'd click on these links and see exactly what's going on here. What is Big Tree, right? Like this should be interesting to us some way now. Okay, so that's one way we can do some enumeration manually with the browser. We're going to check this out. Cool. But I showed you some tools. Let's look at Derby. I'm going to look here, how to use it. Did I show instructions for how to use Derby? Derby. Give it a URL, target host, and a word list. So let me show you what those word lists look like so it's super clear what exactly is happening. Kali has a whole bunch of word lists. I'm going to show you where they are. It's in user, share, word lists, right? I'm just going to show you what we have here. We have a whole bunch of word lists. You guys remember Rocky, right? Way back when, good times. All right, so let's look at Derby, CD into Derby. We have a whole bunch of lists here, right? Cat common or head common. Okay, let me do less common. This one should be good. So you see this list here of just words separated by new lines. We're going to use this word list and we're going to send requests, right? We're going to send requests to 10.11.171:80/AOL/AP/APAC/Apache/ every single one of these. Okay? We're going to make all those requests, and based on the responses, we'll get to know if something was there or not. And so to use Derby, super easy. Derby, let's follow the instructions. Derby, URL target host, word list. Derby, 10.11.1.71. Cool. Word list. User, share, word lists, Derby. And we're going to use common. And let it run. Gotta put host. I gotta do this stuff. http:// port 80. And that should be good. Cool. Cool. Now it's doing it. And so essentially what this is going to do is exactly like I said, check all of those domains out. And if it gets a hit, or essentially something that I have chosen as a hit, you can choose based on response code what is a hit. It'll tell me what I can go to. So I can go check this out if I want. Is it going to be interesting? I don't know. Let's find out. Copy address. Let's see what we get here. I don't think this one's going to be too interesting, but oh, port 80. Colon 80. Huh, why am I getting a 10.11.1.71:80/ isn't this opening up? Oh, that's why. Actually here, this is one. Core. Let's grab that one. Cool. What is this? This doesn't look like something that should just be out there on a website. This is interesting information. This is stuff I might want to check out. I don't know anything about it yet, but it does look like something that the website should probably not be exposed. Maybe I see some cron, something maybe interesting, some config example. I don't know. I see this admin, that always gets me interested. That sort of stuff. Let's not look at that. Let's not get interested in this. What we're interested in now, though, is using Derby, right? We use Derby to find new stuff. Okay, so we could use Derby to do that. Other tool, very similar, is Derbuster. You just run it in the command line like that, or I think you can actually open it up here. You can open it up there if you like. So you open up Derbuster and you hit the GUI version. I don't like this one as much, but some folks do, so we'll try it. 10.11.1.71:80. It looks like it wants it as this, so http://. You can change how many threads you want to do it, so you can speed it up. All right, I'm going to do 15 threads, sure. You do a list, right? So we got to give it a list. You can, right? It's a GUI, so let's find it. Word lists. Here it is, common. We can set some options. So brute force directories, that is, if it finds a directory, it's going to continue doing it for everything inside here, like recursively. If I want to speed things up, I will not be recursive. And then like if I find a directory, I'll manually go check it out, because otherwise it's, like I'm honest, guys, this can take a long time, 30, 40 minutes sort of stuff. And you don't want to be waiting for it. So we'll do that. We'll do that. We'll do that. Sure. and start. And so it'll start doing it like that. I'm also looking for things that have the .php extension. So that might be interesting to me. There's a tree view. So once it gets, once I see some, I'll be able to like see it as a tree and what files are inside what. But this is all just running now and it takes some time. You see it's going. That's how to use Dirbuster. Dirbuster and Derby, your choice, whichever one you want to use. If you're feeling fancy, there's another tool called GoBuster. You can look up that one and install it. It's like a little bit faster. Some people like it more, but it works exactly the same way. There's not too much I want to have to explain about it other than it works exactly the same way. It's not giving me anything. I feel like I should see some stuff. Did I use a wrong list? I feel like I should see something. There's 0 information. Let me try this again. http://1011.171 : port 80. Huh, what am I doing wrong here? You see something, guys? I don't use this one as much. Don't brute force directories or files. Try that. You cannot choose to brute force either files or brute force files. It's just finding things with that.
Matt, did you change lists from common to something called less common?
Oh, did I?
I think maybe.
I'm pretty sure common.
Oh, it's common.
On
No,
Alpha.
common definitely does because I've seen it. I saw it here. Do it in Derby. What am I doing wrong with Dirbuster? This looks right.
Yes, search without a file extension.
Well, you have to choose either a file extension or directories. It's going really fast too. That was weird. I'm gonna check this out. I'll come back to this. This seems odd. It usually just pops them up here and you keep seeing all the responses. Just like as this one was, as Derby was running, it kind of shows you. Same thing here with Dirbuster. I'm gonna check this out. Maybe something's wrong with my copy.
I know what's wrong.
Oh, what did I do?
If you go back to the results,
back to
that part looks correct, but if you start the scan and you look in that area, the URL is just black.
Where HTTP 10.11. Oh, why is it 2 of them here?
Oh, because the directory, you put the IP again in the directory that you're starting with.
Oh, dirt. Just brute force files then. But still, 10.11.170.180. This is correct. Huh. Maybe, that was it. That was it. You caught it. You caught my mistake. All right. So here's what I want to show you. You can see the responses. You can see the sizes of them. You can look inside them. And you get this nice graphical format. Kind of cute. I'm pretty sure you could save the output as well. I think you can. I don't often use this as much because I just use the command line. It's a little easier.
I believe you could use the report button on the bottom right.
Oh, I'll do it. There you go. Save it as you like it. Cool. Other one I wanted to show you is Nikto. So let's take a look at Nikto. Go --help. Okay. And then what do we do? Oh, look, it even tells you if you want more, you do -uppercase H. So I'm just going to follow what I wrote here. Nikto. Good thing I'm fixing that. -H. .11.1.71. I might have to put a :80 here. Or it might do it automatically. Cool. I already recognized port 80. And so this scan usually takes a bit of time and gives you a ton of information, some more useful than others. A lot of times this will be information you may have gotten from somewhere else, but it's often good to get confirmation. And so you'll get a whole bunch of stuff right here. Some of it useful to us, some of it not as much. Like I said, I'll often have this running in the background. And then like once I get stuck after a while, I'll come back and look at it and be like, oh, maybe there's something here, right? Ooh, This site appears to be vulnerable to shell shock. This site appears to be vulnerable to shell shock vulnerability, right? Look, and even links to the vulnerability. I can copy that address and go look at it. What is shell shock? I don't know. Boom, links right here. You get information specifically about that vulnerability. Read up into it. And we're going to go through how to actually read these later on in the course. But here you can easily see, all I did was type in nicto-h, give it a target, and it's just giving me information saying, look, it's vulnerable to shell shock. I don't know about shell shock yet, but maybe it's something I'm going to research about this now. Cool. Any questions on Nikto? I think it's an easier one to use, but the big trick is don't wait for Nikto. Like you see a web server, run it, throw it in the background for a while. You don't have to come back to it. You come back to it later. Okay. WordPress scan, I need a site that's running WordPress on to show you, but just know when you see WordPress, well, let's try WordPress scan on it. Okay. Burp Suite. I'm going to show you this one tomorrow. So we're running out of time. You can do it tomorrow morning. It's a really cool tool, but you're not missing out on anything right now by not seeing it. And the other, of course, most important tool is going to be your eyes and your thoughts, right? All of this is very difficult, and all of it is going to take like many steps as far as logical steps. And so you really have to pay attention, loop back over where you've been sort of situation, a lot of kind of hitting your head against the wall until things start to make sense. Cool. So let's talk about the summary of Active Recon, and then we can actually get some time to practice some of these tools. So Active Recon is how we are going to understand our target, right? We are using Nmap as our eyes and ears, using the DNS as our eyes and ears. And we're looking for what kind of services are running. We're looking for who is on the network. We're looking for what versions of those services. We're really just looking for any kind of information we can gather. And that's what we're going to be spending today, tomorrow, and really all of Red Team doing constantly. It's like an iterative process of, just going to do some research, Google some stuff, try some stuff, walk back over that same path again when things don't work. And that is going to be the process of Red Team and hacking constantly. Okay. Questions before we move on to actually practicing some of these tools, some of this enumeration ourselves.
So like, is roughly this point about the time when, I mean, not now, obviously, but in the future, like how do I phrase it? Would this be the type of stuff that we would be writing scripts for to just automate, or are we just?
So, the answer to your question is yes. Every time you see something boring or you're repeating it, you should be thinking, oh, I could probably write a script to do this for me. And yes, for a lot of the tedious tasks that I've been asking you to do, there are already scripts that other people have written that will do a lot of the work. There is a script where there's a tool called Auto Recon. I don't want you to use it at all until the last week of Red Team. It's going to give you way too much information. It is a tool that automates using a whole bunch of these scripts. And you do it and you get a bunch of information, you don't know what to do with it because you didn't start small and kind of grow. So yes, the answer to your question is, of course, there are scripts that are out there, and there's scripts that you're going to eventually develop to automate repeating stuff. But I don't want you to feel as though there's not value in manually enumerating these things. There's a lot of stuff you're going to miss if you don't manually, with your eyes, look through each of these sorts of lines stuff. So that's my answer to that. Do you have anything to add to that, Frank, as far as automation for now?
So would just piggyback on what you said, like, right, you need, the bigger tools are going to be more hurtful than helpful if you don't understand what they're doing, like if you don't understand what's going on, right? So you have to kind of get used to looking and working with these tools and understanding their output and knowing what that means before those tools will be actually useful for you. And then once you get to that point, those tools are very useful. And then you also have to be able to understand like what the tools are doing and what they're not doing, and what are the holes being left that you need to fill in yourself. you start using them now, right? You're going to get some easy wins, and you're just going to end up being in a situation where if the tool doesn't find it, you don't know how to find it. So
yeah, that's exactly right. It ends up, I don't want to say becoming a crutch, but you always use the tool. And like Frank said, if the tool doesn't find the thing you're looking for, then you won't find it because you don't know how to look for it yourself. So yes, hold on till the fourth week of Red Team. Then we'll show you some fun, power tools, I guess. But until then, we're going to kind of do things a bit manually. And you'll get more value out of doing things manually like that. Okay. Let me end this recording then. And